Hey Tigers, we are going to be looking at page 30 of your notes, and we are going to be talking about using statistical measures to compare populations. All right guys, our essential question today is how can you use statistical measures to compare populations? We do have a vocab term today, and that is the mean absolute deviation. We sometimes refer to that as the MAD, because mean absolute deviation, M-A-D, MAD. So the mean, or the average, distance between each data value and the mean, or average, of the data set. Okay, so that's what the mean absolute deviation is. Okay, absolute, okay guys, that means that it is always positive. Okay, absolute value, mean absolute deviation is always positive. All right, so calculating the mean absolute deviation, or the MAD. Okay, step one, you guys are just going to find the mean of the data set. All right, so that's just the average. Remember, to do that, we add them all and then divide by the number of numbers. So what we're going to do here is first we're going to do exercising. So we need to find the mean of all of these numbers, okay? So if we add all of these together, so if I've added them all up, I get 204. Okay? And then if I count up these numbers, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 numbers, which means to find the mean of exercising, we would do 204 divided by 12. Okay, if I do 204 divided by 12, I get a mean of 17, and that's for exercising. Okay, we're going to do the same thing for video games. Okay, so if I add all of these together, I get 350. Okay, figure out the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this one also has 12 numbers. Okay, so for the mean of video games, I'm going to do 350 divided by 12. Okay, so when I do that, I get approximately 29.2. So that is for video games. Okay, so those are my means, right? Step two is we need to find the absolute deviations. So deviation means like how is it different, okay? So what we're going to do is we're going to subtract the mean from each data point, and no matter what, even if you end up with a negative number, you're going to write your answer as a positive. Okay, so let's go ahead and do exercising first. Okay, and I'm going to color code these so it's a little bit easier to tell them apart. So for exercising, let's go ahead and do blue. So our first number is 0. So we're going to do 0 minus 17. Okay, our second number is 7. So 7 minus 17. Third number is also 7. 7 minus 17. Did the comma instead. Okay, 18 minus 17. 20 minus 17. 38 minus 17. So this is going to be like 12 things we got to do here. 33 minus 17. 24 minus 17. 22 minus 17. 18 minus 17. 11 minus 17. And 6 minus 17. All right, so we're just going to actually do those subtraction problems. And now, you've got to remember, no matter what, it's going to be positive. So even though 0 minus 17 should be negative 17, our answer is just going to be 17 because it's always positive. Okay? Always positive. 7 minus 17 would be negative 10, so it's just 10. Again, just 10. 1, 3, 11, 21. I carried away there. So that's 21. 33 minus 17 is 16. And 7, and 5, and 1, 6, and 11. All right, so there are all of my numbers. Those are all of my absolute deviations. So now that I have my absolute deviations, now I need to find the mean of all of those. So if I add all of these together, okay, I add 17, 10, 10, 1, 3, 21, 16, 7, 5, 1, 6, and 11, I get a total of 108. Okay, then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 numbers. So that means I have 108 divided by 12. And that gives me 9. So I have a mean absolute deviation, or a MAD, of 9. Okay, let's do the same exact thing for video games. And I'm going to make video games pink. All right. So this one, guys, is going to be a little bit trickier because we do have that decimal in there. So we are going to have a lot of decimals. So all I'm going to do is I'm going to write down each of these numbers in the data set minus 29.2. Okay? Okay, 32 minus 29.2. All right, so some of these numbers are a little bit bigger, so I am going to have to go down to another line because I ran out of space here. So let's see, where did I leave off? 36 minus 29.2. All right, guys, sorry about that. So my camera froze a little bit, so while it was frozen, I finished writing down all of these numbers. Now all I'm going to do is the same thing I did on the exercising. I'm just going to figure out what the difference is between the two. And keep in mind, it is always positive. Okay, so 16.2, 11.2, 10.2, 0.8, 2.8, 16.8, 20.8, 4.8, okay, 6.8, 0.8, 6.2, and 10.2. All right, if I add up all of my red numbers, all my differences, that's how I'm going to calculate my MAD. All right, so when I add all of these together, I end up with 107.6. Okay, and I still have 12 numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm still going to divide by 12. And that gives me, I'm going to get a weird funky decimal number. I'm just going to round it. I get approximately 9. So this one also has a MAD of 9. Okay, this one is exactly 9, and this one is approximately 9. Okay, so it's just like finding the mean, guys. You just have some extra steps that you have to do in between. Okay, all right, and then down here at the bottom, we've got one more section. So it's using multiple samples to compare populations. Okay, when you use multiple samples to compare populations, you should compare the means and the medians of each sample. Okay, you compare them the same way you would compare any other data set. So check through page 28 and 30. Okay, you're just comparing medians instead of the individual data points from each sample. Okay, so the reason we're going to do that is because medians vary less than actual data, so you're going to get a more realistic comparison. And you guys should look back at page 29 specifically for that. Okay, so for example here, we would compare the median here, which is 9 for grade 7, and the median of 11 for grade 11. Okay, so even though they have some pretty wide spreads, comparing the median is going to give us the best kind of look at the data. Okay, all right, guys, so last thing is, as always, if you have any questions about this lesson, please put them in the Your Question column. And then at the bottom here, please make sure you look at the summary question, and remember, it is an explain question. So I care more about your explanation than the answer itself. So explain in your own words why it might be a good idea to use multiple random samples when making comparative inferences about two populations. Okay. Like I said, you guys can refer back to your notes on page 29. You guys can also look in your textbook. We will talk about this in class.